Do you want to master the 8 laws of logarithms? Here is a quick tutorial showing how to get it done. The first law of logarithms is the product rule. The logarithm of a product is the sum of the logarithms. Consider simplifying log 30. Log 30 does not have an obvious base, so we will assume the default base 10. It is helpful to use prime numbers when simplifying log 30 because prime numbers quickly reveal the relationships between bases and exponents. Consider another exercise, which involves simplifying log 450. Log 450 does not have an obvious base, so we will assume the default base 10. Notice that the simplified form is expressed as logarithmic functions having prime numbers as their bases. The second law of logarithms is the quotient rule. The logarithm of a quotient is the difference of the logarithms. Consider simplifying the logarithmic function of 8 multiplied by the 4th root of 5 divided by 81. Simplify 8 and 81 using prime numbers as the bases expressed to rational number exponents. You will occasionally need to use the laws of indices to achieve simplified forms. The laws of indices have been discussed in previous video tutorials. Links to the full video tutorials are available in the description. Also click on the link at the top right-hand corner of your screen to see all videos in the playlist of this channel. Remember to change the 4th root of 5 to become 5 raised to power 1/4. The final simplified form is expressed mainly as log 2, log 3 and log 5, which are all prime numbers. The third law of logarithms is the power rule. The logarithm of a number raised to a power is the same as the whole logarithm being multiplied by that exponent, after it has been moved from its exponent position to a coefficient position. Consider an exercise to simplify log 64 minus log 128 plus log 32. Log 64, log 128 and log 32 need to be simplified to log 2 expressed as different exponents. Then move the exponents to the position of coefficient just before the log function. The final simplified form is 4 multiplied by log 2. Consider another exercise, which involves simplifying log 25 minus log 125 plus half of log 625 all divided by 3 multiply log 5. Break down these logarithmic functions and express them as log 5 with powers. 5 is a prime number. Use the laws of indices to achieve simplified forms. Watch till the end to see the math tips, tricks, and problem-solving strategies. The final simplified form is 1/3. The fourth law of logarithms states that the log of 1 is always 0, regardless of the base. It can be better understood by changing from logarithmic form to index form. The fifth law of logarithms states that the log of the base to itself is always 1. To ensure clarity, I will label the different elements making up the logarithmic function of the fifth law. The key elements are the number, base and power, also known as exponent. We will set up the number and base such that their powers can be divided. The sixth law of logarithms resembles the fifth law. For a logarithmic function where the base and number are alike but their exponents are different, simply divide the exponent of the number by the exponent of the base. The sixth law of logarithms is a hybrid of the third and fifth laws of logarithms as demonstrated here. The seventh law of logarithms states that the base raised to the log of a number returns the number. Consider an exercise to simplify 100 raised to log x squared. Log x squared does not have an obvious base, so we will assume the default base 10. This is an important step to implement before using the seventh law of logarithms. Change 100 to 10 squared, then multiply power 2 and log x squared. Move power 2 from the coefficient position before log x squared to the exponent position to get x squared raised to power 2. The final simplified form is x raised to power 4. The eighth law of logarithms states that the inverse of a logarithmic function will switch the number position to the base position and vice versa. Consider an exercise to prove that log A with base b can be inverted, and the result would be 1 divided by log b with base a. Before splitting a and b to get different logarithmic functions, ensure to use the same base in the derived splits. Here we will use base 10, although the law allows us to use any other base provided it is the same base in the numerator and denominator of the fraction. This is the premise for implementing the 8th law of logarithms correctly. Watch till the end to see the math tips, tricks, and problem-solving strategies. Congratulations for reaching this point in the video. Your knowledge of the laws of logarithms is assured. If you learned something from this video, please like, comment and share it for reach. Feel free to subscribe for more videos and let me know what you would like me to discuss in future video tutorials.